we'll start with this. There are two types of wave, what we have already seen. One is transverse wave, the other one is longitudinal wave. So now the speed of the transverse wave on a stretched string. So you're going to derive an expression for the speed of the transverse wave based on the method of dimension. Just right, boys. Speed of transverse wave on a stretched string. So it depends on two factors, tension in the string and mass per unit length. So I can write velocity V is proportional to tension and is also proportional to mass per unit length.
Ma'am, I think we skipped something.
Which one?
Ma'am, so could you show the previous slide?
Okay. This one? Wave number?
Ma'am, we didn't discuss the second thing.
Yeah. Was angular wave number or propagation constant. It's 2 pi by lambda. We'll discuss this wave number later on when we start deriving an expression for the progressive wave. The propagation constant. So let us start with this. The speed of a transverse wave on a stretched string. Velocity is proportional to tension, and it is also proportional to mass per unit length. So by the methods of dimension, so I can write V is equal to K times tension is nothing but the force, then mass per unit length. I'll just take it as M to the power of B. So now you have to go for writing the dimension of tension. Tension is force. So what will be the dimension? ML T to the power of -2. Okay, mass per unit length, mass by length. So it has a dimension of ml to the power of -1. So velocity, I can write it as L to the power of tension, I can write it as ml to the power of -2 to the power of A, and mass per unit length. So I have to equate the coefficient of ml on and T on both the sides. It will be A plus B. Length has a dimension of A minus B. Then time has a dimension of -2A. So now you equate the dimensions of M, L, and T on both the sides. Get me what is the value of A, what is the value of B. Find what is A, what is B. And will you do it by yourself, boys? Just calculate. You have to equate the dimensions of mass. When you equate the dimension of mass on both the sides, left hand side will be 0, right hand side will be equal to A plus B. So this will be A plus B. When you equate the dimension of length, so it's 1 is equal to A minus B. And equate the dimension of T to the power of -1, here T to the power of -2A. So equate and get me the value of A, B, and C. Or you can go for, A and B, and then we'll go for the equation for the velocity. Did anyone find what's the value of A? What is A plus? Shall I erase? Half, right? Yeah. A is half, B is?
-half.
Correct, B is -half. So the value of A is half plus half, B is -half. So how will your equation look like, boys? Your equation will be velocity v is equal to, you can put some constant, root of t, because t to the power of half means square root of t is t by m, because t is raised to the power of a is plus half, m is raised to the power of b, which is minus half. So it will be square root of t upon m. Did you all complete this, boys? So this will be your final expression. V is equal to c into t to the power of square root of t divided by square root of m.
Ma'am, C
Yes.
is the constant.
Constant,
known
any
as-
constant.
Okay.
No, because this is the problem in dimensional analysis. So just I have put a notation as C. We can't evaluate the value of C if I'm going in the, sorry, if I'm solving this by the methods of dimension. This was one of the drawback. So we don't know exactly the value of C. Just we keep it as a constant. Shall I go for the next one, boys?
Yes, ma'am.
Okay. Next one, speed of a transverse wave in a solid. One second. The previous one was a stretched string. Now it is in case of a solid. Solid, it depends on the elasticity of the medium, boys. Now, generally, what happens when energy enters, suppose if I have a medium, now before the energy or the disturbance enters into the medium, all the particles were initially in the state of rest. So when your energy enters to the medium, it makes the particle of the medium to vibrate. Now, say if it is a solid, right? Now it will encounter the first atom, say. Now this atom has to vibrate, complete one full oscillation, then it comes to rest and transfers the energy to the second particle. Are you clear, boys? So then this second particle will vibrate, then it comes to rest and transfers the energy to the third particle. So if the speed of the wave has to be greater, then the transfer of energy should be fast. Transfer of energy from one particle to the other particle should also be of a higher value. How fast the energy is transferred from one to the other particle, that determines the speed. If the first particle, if it takes a long time to transfer the energy to the second particle, then the speed of the wave will be less, right? Now, the transfer of energy, if particle one has to transfer the energy to the second particle, then the first particle has to come down to rest immediately at a very faster rate, which means the elasticity. In a solid, all the atoms are strongly held by interatomic forces of attraction. If I consider an atom, now this atom can vibrate, but this atom cannot easily come out because it is being strongly pulled on all sides by the other atoms. It was so. If this atom gets disturbed, it comes to rest immediately because of the strong interatomic forces. That is a force which doesn't want the particle to move out from its rest position. It tries to bring the particle back to the normal position. So the elasticity of the medium should be high because the particle one can immediately come to rest and transfer the energy to the other particle. So if the speed of the sound wave has to increase, the atom should be highly elastic. Highly elastic means what? It has to vibrate, come back to its original position at a faster rate, and then transfer the energy. That is why elasticity of the medium. So generally, when you state about elasticity, elasticity, let it be Young's modulus or rigidity modulus or shear modulus. For that matter, it is elasticity is nothing but stress by strain. Now, strain is a dimensionless. Suppose if I want to find Young's modulus or the elasticity, the dimension of elasticity, it will be only the dimension of stress, because strain is a ratio. It will not have any dimension. So the dimension of elasticity is equal to the dimension of stress. That is nothing but force upon area. So when what you can do is your velocity is proportional to, I can write the elasticity as eta, right? So elasticity to the power of A, then mass per unit volume. What is mass per unit volume? I can write M upon V, mass per unit volume, capital V, to the power of T. Will you be able to evaluate, boys, the value of A and B?
Yes, ma'am.
Okay, do that, boys. So I can write.
Ma'am, do these two derivations have any do they have any diagram?
No, nothing. It's
Alright,
only the
ma'am.
introductory, boys. It's only the introductory part. Instead of giving you the formula, I'm making you to derive. That's it.
Okay, ma'am.
Okay, will you be able to do, or should I do? So if you go for the elasticity, this I can write it as eta. Right? The dimension of elasticity will be equal to the dimension of stress, because strain has no dimension, it is a ratio. So stress is force upon area. So what is the dimension of force? ML T to the power of -2, but the dimension of area is L squared. So it will be ML to the power of -1 T to the power of -2. If I go for the dimension of velocity m0, L T to the power of -1 is equal to K into eta. Eta, it will be M L -1 T to the power of -2. Same way to the power of A, mass per unit volume M L to the power of -3 to the power of B. This becomes K into M to the power of A plus B L to the power of -a minus 3b t to the power of -2a. Now you can equate dimensions of m, l and t on both the sides. Let's check, boys. Yes.
A is half, B is negative.
Yes. Correct. So your value of A is plus half, B is so you'll get this as your equation will be V is equal to K times root of eta by mass per unit volume. You can write it as m also.
Ma'am, could you tell one more time why it depends on elasticity?
Elasticity is that, boys. So the medium should be elastic. See, suppose if you want to transfer energy from one end of the medium, suppose if it is a solid, I want the heat to be transferred from one end of the solid to the other end. Now, what happens when energy enters a medium? It disturbs the particles of the medium, which means the particle begins to vibrate. Each and particle in that sense, atoms. Each and every atom has to vibrate. It has to complete one full oscillation, comes to rest, and then it has to transfer the energy to the other particle. This is how transfer of energy takes place. If one atom is going to transfer the energy to the neighboring atom, if the transfer takes place faster, then the speed of the wave will also be of a greater magnitude. So when atoms can transfer the energy faster, one way is that, see, in gaseous medium, what happens, your atoms or molecules are far away. So the transfer of energy will take place a long time. But whereas this way also you can state, in case of solids, all the atoms are closely spaced because of their strong interatomic forces of attraction. They are closely spaced. And since the other neighboring atoms will pull back the molecules at a faster rate, if one atom is going to vibrate, it can be easily brought down to the state of rest by the other atoms because of strong intermolecular forces of attraction. That the cause of elasticity. Each and every atom should be elastic in that sense. It has to vibrate, come faster, come back faster to its normal position, then transfer the energy. If it takes a long time to come back to its original position, then it cannot transfer the energy to the second one. So how fast the atoms are going to transfer the energy depends on determines the speed of the wave. So how fast it can transfer depends on the how elastic the medium is.
All right, ma'am. Okay. So it's like directly proportional.
To the elasticity.
Okay, ma'am.
Ma'am, could you tell why we write M instead of density, like in the final formula?
Mass per unit volume, yeah, you can go for D also. Mass per unit volume is D, yes. You can put D also. If you feel M is tough for you. Density generally we go for rho. D represents distance, rho represents density. Then you have to be, yes, I can put this as
Ma'am, like for the previous one, should we mention anywhere that it's mass by length, like in the
mass per
denominator?
unit. Yes, it's mass per unit length. Important was.
Okay, ma'am.
Next year, if you have your normal session for grade 12, you will be doing an experiment on the previous topic. So there you will understand what is mass per unit length.
Ma'am, by the way, do you know when is the physics practical test for a
Physics practical test, it will start from 11th to timetable will come up, boss. 11th to 16, only 3 experiments. Whatever you have done in O lab, we are just finalizing which are the 3 experiments. By today, we will let you know, because those experiments should be related to your theory part. Only 3 we are going to do, 5 questions from each. So totally 15 marks, right? It will be in MS forms, 15 questions, 5 each from 3 practicals which you have conducted in O labs. So 15 marks will be converted to 30 marks. Right, boss? Are you clear? Your practical is of 30 marks. Of 30, so you will be given a paper in MS forms, fully MCQ. It will be 15 questions. 15 questions, 5 from 3 experiments. 5 questions per 3 each experiment. Totally 3 experiments. So it comes
Ma'am,
to
so
be
for each experiment, it's going to be on 3 different days or all
no,
together in one
no,
test?
altogether physics as a whole in a day. I think so. You will be having a 0 period. So in 0 period in MS forms, you'll be completing your
Okay, ma'am.
test. Okay, and your theory, for your theory, it is a 50 marks paper, right? Should I write in a blank slide?
Ma'am, like the
Ma'am, it's like
final
PT2,
exam
right?
theory.
50 marks and then, ma'am, it's like
No,
PT2, right?
everything will be, yeah, everything will be
60
given.
marks and then 20 marks
20
MCQs.
marks will be for MCQ.
Yeah,
30 will
and
be
even in the 50 marks, will we have the self-evaluation like last time?
let us check, boys, because they want you to check that. That you need not worry, it will be told to you, right? So 50 marks, then 30 marks will be your theory. 50 out of 50, 20 goes for your MCQs. That is in Microsoft Forms. In that MCQ, you will be having assertion and reasoning based as what you have seen in the previous paper. Then 30 will be your theory and 50 will be converted to 70. Your practical 15 will be converted to 30. Theory 50 will be converted to 70. It's a 2 hours paper.
Ma'am, like, will all the chapters then be there for the
Yes,
exam?
boys. Yes. What we'll do is that we are not deleting any chapter, but suppose if I'm giving an example of units and dimension, you will not have all the topics because those two chapters are already being tested. Might be error analysis would be a part. That's it. The first chapter you will have to learn. I'm giving an example. First chapter you will have only error analysis. Second chapter you might have only equations of motion. That's it.
Ma'am, so like,
Mm.
for now, can we just learn the latest chapters and then
latest
you give
latest
us
chapter will carry a weightage and understand oscillations and waves. Whatever we are right now doing will be carried over to grade 12. So we are giving more importance to those chapters. That is why we left the 3 chapters in between and we started with this. The 3 chapters, kinetic theory of gases, it's already a very small chapter. Your CBSE board has again deleted certain topics, right? You have a revised one, then thermodynamics also, then thermal conductivity. These 3 chapters which will be taught next, we will teach whatever is being revised, but we will test only few topics from that. Okay. The next 3 chapter, whatever the CBSE syllabus has prescribed, we will teach you, but we will tell you which are the topics. There also we'll select which are the topics you will be tested. Is that clear, boys? Suppose if I say thermodynamics, there are 5 different topics, subtopics, which CBSE is recommending, revised syllabus. We will teach all 5, but you will be tested. You will be writing exam only on certain topics. Might be 2 topics.
Yes, ma'am.
Are you clear? So those 3 chapters will not be a burden for you, boys, because we don't want to put a burden on you. Those 3 chapters are not anyway carried over so much to grade 12. So whatever CBSE has prescribed, we will do all those topics, but you will be tested only on important things for those 3 chapters and first 2.
all
Shall
right,
I?
ma'am.
Okay. Shall I go for the next one? Now, speed of longitudinal waves in a liquid or a gaseous. So whenever you talk about a fluid, the elasticity is only your volume elasticity.
Ma'am,
What is?
ma'am, can you show the previous slide? Yes, ma'am.
Whenever we are talking about this longitudinal waves, sound waves generally, in a liquid or a gas, for a fluid, generally we go for volume elasticity. Now, what is volume elasticity? Suppose if I have a gaseous enclosure or a liquid, say enclosed in a circular enclosure, which has a volume V. Right? Initially, the pressure would have been P. Now you are applying a normal force, right? You are applying a normal force acting on the surface so that its volume decreases to V dash, and the decrease in volume, the volume reduces by an amount delta V so that the new volume becomes V dash. Is that clear, boys? The fluid is compressible. So now in this case, how elastic is your material? That is nothing but force acting per unit area divided by change in volume divided by original volume. What is the change in volume? The volume has been decreased by delta V. So change in volume by original volume. This is what is volume elasticity. Now, change in volume as well as volume will have the same dimension so that their dimension gets cancelled off. So then your volume elasticity will be nothing but force upon area. Are you clear, boys? Are you clear? Whenever you're talking
Yes,
about
ma'am.
volume elasticity, it is force acting per unit area, that is nothing but the pressure, divided by change in volume divided by original volume. So change in volume and original volume, these two, they don't have dimension, they have the same dimension, so that it gets cancelled off. So it's a ratio, delta V by V. So what is happening is that they don't have any dimension. So then the volume elasticity now only has the dimension of pressure, that is nothing but force upon area. And now density of the fluid will you be able to do this, boys? By methods of dimension, will you be able to find an expression? Density, let it be rho. Okay, do by us. Find. So this will be volume elasticity. I'll put it as this is rho. So V is proportional to some C times eta to the power of A, rho to the power of B. So the dimension of V is m to the power of 0, L t to the power of -1 is equal to some C times eta will have the dimension, boys, elasticity, that is force upon area. Stress, it has only the relation of stress. So it is m L t to the power of -2, that is force. Area is L squared. So that will be m L to the power of -1 t to the power of -2. So I can write m L t to the power of -1 to the power of A. Then density, what is density, boys? Density is mass by volume. So this has a dimension of m. Volume is L cube, that goes to the numerator as L minus 3. So m L minus 3 to the power of B. Can you find the value of A and B? Boys, if you feel that eta is tough for you to write, instead of eta, you can go for K. You feel can go for K also.
For the previous one, like
Yes,
Siddharth, you can use
it's not
rho instead of m.
Yeah, you can. Yes, notation. Okay. So what is the value of A and B here, boys? What is the value of rho? Are you doing, or should I do, boss? Should I solve? 11C. Sorry, 11B.
No, we're doing.
Okay. Anyway, I'll try to do. First, this will be M0 L t to the power of -1 C into, I can write this as m to the power of A plus B, then L to the power of minus A minus 3B, then it will be t to the power of minus 2A. So when you're equating the coefficient of ML, So 0 is equal to a plus b. Then I can go for the last one. Minus 1 is equal to minus 2a, or I can write a is equal to plus half. Then if I substitute.
Ma'am, b is equal to minus 1 by 2.
Yeah, correct. B is minus 1 by 2. A is equal to plus half. Then you can go for the equation. V becomes equal to C times root of K divided by rho. So this is the speed of the longitudinal wave. Generally, if whenever you go for a longitudinal wave, the first one which comes into your mind is sound waves, because sound waves can travel through a gaseous medium. So the velocity of the sound wave in a medium is given by the equation V is equal to C root of K, that is the modulus of elasticity of the medium, divided by rho. How elastic the medium is. Yes.
Ma'am,
Yes.
on the start you have written density equals to mass by volume, right?
Correct. Mass by volume.
Ma'am, yeah, on the right side.
Right side is.
That's okay. Thank you, ma'am.
Now, this is the equation given by Newton, that is the expression for finding the velocity of a sound wave. Longitudinal wave is a sound wave in a gaseous medium. Now we'll see there should be some correction to that, and that correction was given by Laplace. So I have to finish that.
Ma'am, here instead of neta, we should write K.
Yeah.
Okay.
Can go for eta. No, there also you can go for any notation. If
Okay, ma'am.
you feel that eta is tough, you can go for K.
All right, ma'am.
Shall I go for the next one, boys? So this is the equation for the speed of longitudinal wave in any gaseous medium. Next one, speed of a longitudinal wave in a liquid or a gas, that's Newton's formula and Laplace correction. Whenever any scientist for that matter, if they derive an expression, now that
Ma'am,
so tomorrow, boys, you have 0 period, right? Because I need to take a 0 period. Portions need to be completed, boys. So I might, someone is taking your 0 period tomorrow? No.
No, I think chemistry, ma'am.
Chemistry, ma'am. So anyway, I'll talk to chemistry, ma'am. Half of your period might be half an hour. I'll take the rest half an hour. She'll be taking, because we need to complete your portions, right, boss? I'll request you. You can leave, boss. You can leave.
Thank you, ma'am.
Thank you.
Thank you,
Thank you, ma'am.